Good evening, good afternoon, everybody. It's a pleasure for me to welcome everybody here in the room. And to be crystal clear at the beginning, this is not an OPC Foundation event here. The wall is here because we rented this room. We had another event today in the press conference, but we moved that out here from the stage to clearly address this is an event and from all the associations where you see the logos here together. And I'm just here right now, the moderator, and that's it right now, okay? So this is event, you have maybe read the article in the newspaper today, but also all the associations have agreed to a joint press release, which has been sent out through different distribution channels. You should have received them. If somebody's in the room who has not received one of that press releases through different media channels, you are really disconnected and you should subscribe by all of the associations, right? Okay. To show you quickly what we are doing today, it is a little bit small maybe, but this has been published also, and I'm reading this just briefly. So we have a short welcome from Thomas Hahn from Siemens. He's in his role as a coordinator of the International Manufacturing X initiatives and activities. And then, and this is, I believe, most of you are here in the room, we have a presentation from he himself. He showed up, Erich Barnstedt from Microsoft, telling us how everything fits together, and we all like to listen to him about these great ideas. And then we have representatives from all, or from the major standardization bodies doing statements, and we have overall 6 speakers, and we try to stay within 25 minutes, and I'm asking all my co-speakers to keep it short and crystal clear, and then we have also a chance for some Q&As. I believe that all of you know the associations in detail, and we don't have to start from scratch educating you on all of that. Yeah, and then we have a Q&A, and round about 1 hour, a little bit more than 1 hour, depending on your questions, we will finalize this event here. There's no rush later on. There's no other event after this event. So if you like, we can stay here for the whole night and discuss everything. And Erich can answer all the questions while. So I'm staying for the whole night? You are staying here. I will have dinner and have a beer. Okay. Okay, with this, Thomas, I'd like to invite you to give a short statement here on this initiative from your point of view. You have been, maybe let me tell this no. I believe that both, and this is why both Thomas Hahn and Erich Barnstedt are the first speakers. I believe that they managed a lot to make this happen, and this is why I think we should thank them both. But let's start first of all their statements. Good.
Okay. Okay. Thanks, Stefan. And first of all, apologies that I was a little bit late because I was running from hall number 10 or 11 entrance, don't ask me, just from the other side, to this building. As usual, as the fair, you're always a little bit in delay with the meetings. But let's set a little bit the context about data ecosystem manufacturing or manufacturing X initiatives, and why it is so super important to set up this joint work, which Erich will make a deep dive, or the colleagues will speak later about this. And you know, I'm always, I think sometimes I'm boring, but why this is important, I am starting with a short use case, or 2 use cases. You know, when you are speaking about data ecosystems, when you're thinking about a product carbon footprint, reporting or better optimizing, then you see at your own factory floor, and now this is what we are producing. Of course, when you're producing steel or something else could be slightly different. But when you are in factories from our company, you see maybe 10 or 20% of the CO2 footprint. So the remaining part is upstream and downstream, so meaning you have to have some kind of data transparency, data ecosystem, and at the end also some kind of interoperability about to exchange the data, because on the other way you can never ever, sometimes not fulfilling the regulation, but more better from industry speaking, make some kind of efficiency in your production, or to look for new business opportunity. Also not only the regulation part, but also the business part, which we have to keep in mind. Or I'll give you another example. It's a little bit closer. What is here written down as a battery passport? When you have a battery and you know how the battery is produced, used, assembled, the complete chain, then you can recycle it much better. Can recycle, don't ask me, 94 of the ingredients of the battery when you know how have this all this, because then and this now we're speaking also about an impact on our environment, where we can save topics, or you can also, again, the same story, optimize the production, the recycling, and at the end improve your businesses. This is all about, let's say, why this is super important to have this transparent, interoperable exchange of data and information about the data, let's say, on agreed on. And now I'm speaking agreed on a international level, because as you can immediately imagine, only when you're thinking about batteries, there's materials coming around the world, so you have anyway distributed value chain where you have to look inside and to handle this. And when we're speaking about the international, and I think you see on the left side the logo of the International Manufacturing X, we set up some kind of cooperation between different regions of the world. Also we launched this operation, or this cooperation, not operation, cooperation, in October last year out of Tokyo, where we brought people from Korea, Asia, Europe, European countries, different European countries, US, Canada, Australia, together. Other countries are knocking on the door. For standardization, for example, China is knocking on the door. It's not a topic, not a surprise. And the same for India. I expect this would be quite interesting, because it's at the end what is needed, that we're looking what we can achieve together and to agree on together. So this is a little bit the history. So we set up between different regions a collaboration called International Manufacturing X, and Manufacturing X is for us a term of initiative where we are looking about machine tool building use cases, Factory X, where we are looking about a semiconductor business, where we are looking about chemical, for example, I think I can tell this, also for chemical passport is a material passport, must be precise, is setting up some initiative which also contribute to this digital passport journey, where we are setting up some kind of international cooperation. And as said, we have shown this, or to be precise, Erich has shown this and myself last week in Oak Ridge, Tennessee. There was one of the next meeting from the International Manufacturing X Council. Again, colleagues from Europe, Asia, and Americas were present, and Australia were present, and we're showing this how we are joining, let's say, our forces. Matthias was there. Erich was there. Some of the other colleagues, Nina was there. Sorry, I forgot somebody. But we have shown this on let's say, on stage in the Oak Ridge. And I think most important thing, we get an applause. We get a good applause. We got a very, very good applause. So. Yeah. So we were not close to standing ovation. Let's phrase it in this way. No, but jokes aside, we get really and buy in and saying this is really the way forward in doing this. And it was a pleasure for me. And thanks, Stefan. Yes, Erich and myself have pushed a little bit. Also our organization, Stefan, when they're thinking about OPC. Okay, pushing this a little bit to get it done. And as Stefan said, this is not an OPC meeting here, it's a joint meeting, and that's the reason why we have the complete colleagues here sitting on stage, because we have to do it together. And I think super well accepted. And many, many thanks, and many thanks, Stefan, to make this short intro about. And now I hand over to Erich, I think. Many thanks.
Let's talk about the building blocks of the solution that we put together. So first of all, let's talk a little bit about OPC UA and what the OPC Foundation has done over the last few years regarding digital product passport, digital battery passport demos, to prove the technology is able to do that. First of all, you should realize that OPC UA has been part of the asset admin shell specification from the start. So unfortunately, nobody really implemented it until now, so it was hard to demo, right? Because it was in the spec, people saw it, yeah, it's there, but nobody really used it until now. So you can model an asset admin shell with OPC UA. It's part of section 7 of the asset admin shell spec, and this is exactly what we did here to show the technology in work, in practice. Also, there's a companion spec specifically built to show how a mapping from the asset admin shell meta model in the specification, it's modeled in UML, Universal Modeling Language, but in the I4AS companion spec, which every companion spec becomes part of the OPC UA standard. And in the I4AS companion spec, it is clearly defined how the meta model of the asset admin shell can be mapped to OPC UA. Now, some of you may know that the companion spec still uses version 1 of the asset admin shell, but there's a working group inside the OPC Foundation currently bringing that up to version 3, which is the current version of the asset admin shell. And then, of course, some of you know that we've been working on an extended and enhanced REST interface for OPC UA. So REST has been part of OPC UA since 2016. The problem was nobody found it in the spec. So now we have a much broader, more complete REST interface defined for OPC UA. It's going to be released as part of the next iteration of the OPC UA specification. And then last but not least, there's a huge ecosystem of existing OPC UA modeling tools available today. And what do you need to really bring a specification or a standard forward? Well, you have to give people the tools to actually use it. And that's exactly what OPC UA has been doing for the last 20 years by providing all of these modeling tools. Some of them are free, others need to be purchased, but they're very complete and they're very powerful in terms of what they can achieve. I'm going to show one of them later on today. So using that information and using those capabilities, we've built, together with Huawei, thank you, David, a battery passport, and we showed it last year. Actually, no, sorry, this year at HMI, modeling an industrial battery with OPC UA, using the battery meta model that has been defined by Catena-X, and building it into an OPC UA server, showing it with the new REST interface so people could have a look at it. And it was a proof of concept, it worked great, and of course, every battery that is bigger than 2 kilowatts from 2027 onwards must have a digital battery passport associated with it, for industrial batteries and for mobile batteries. So that includes your e-scooters that you see all over the pavements here. They also have to have a digital battery passport from 2027 onwards. And then, of course, together with CESMII, the OPC Foundation built the cloud library. It's been around for 4 years now. CESMII built the cloud library into their smart manufacturing innovation platform. And there's over 150 OPC UA models now included in this cloud library, including all the companion specs that the VDMA has released to date. CESMII have their own instance. The OPC Foundation have their own instance. So for those of you who say, well, we need a fault-tolerant solution, you have it. You can make both of them available in your application. If one becomes unavailable for whatever reason, the other one is in a completely different cloud environment, and you can use that instead as a backup. And they're synchronized automatically. So when an OPC Foundation companion spec is released, the nodeset file is automatically uploaded to the OPC Foundation cloud library and then synchronized to the CESMII version. So with that, we've built an asset admin shell that was already using an OPC UA information model. I believe it was for SPS last year, in fact, so it's a year old. So we modeled a product. In this case, it was a robot. We took the OPC UA model for that robot. We've wrapped it in an asset admin shell, and then obviously the OPC UA model ended up in the cloud library, and the asset admin shell ended up in an instance of the AAS repository that Microsoft had contributed open source to the Digital Twin Consortium. So it was a pretty important demo. Actually, sorry, it wasn't a robot. It was actually a roll of paper. It was a roll of paper. It looks like a toilet roll. Trust me, it wasn't a toilet roll. It's a big roll of paper that we produced. And CESMII calls OPC UA information models smart manufacturing profiles. You just have to know that. And that's their term for OPC UA information models. So then at HMI, like I mentioned, we demonstrated that we can also obviously use a REST interface together with an OPC UA information model, and we even created a browser that leverages that REST interface, and you can see it here. So let's talk about the asset admin shell and its building blocks that make up this solution. So first of all, the asset admin shell defines a number of submodel templates for different parts of a digital product passport, but you can also use them for many other models. Christian, help me out. How many submodel templates do you have now? Almost 100, right? So they're being developed. They're published through the IDTA. They're on the IDTA website, both in PDF form and also, I think, or just JSON, yeah, perfect. So those are available today. And for some of the work that we've done in the OPC Foundation, we've taken that JSON and converted it into the native format of OPC UA, which is, of course, the nodeset2 format. The asset admin shell also has a REST interface. It had that REST interface for quite some time now. It went through several iterations, actually, so it's very complete. And it can be used for both registries and repositories. Now, the difference between a registry and a repository is that, or let's say the registry is the phone book of asset admin shells, and the repository actually contains the individual asset admin shells. So you need both. And then finally, there is a file format that the asset admin shell specification calls out. I was told it's based on Office OpenXML. It's basically a renamed zip with an XML in it which describes the content, right? So if you open your favorite Word document, or if you rename your favorite Word document the docx and rename that to zip, you can actually browse into that zip, and you can do exactly the same with AASX files. They're nothing but renamed zips with a XML set that is called content XML, and you can see all the different parts of the asset admin shell in there, PDFs, 3D drawings, whatever it may be. And of course, it also just has either an XML or a JSON document that describes all the metadata of the actual asset admin shell. And it's exactly that JSON or XML document that we're now replacing with an OPC UA nodeset file. So Labs Network, Industry 4.0, Dominic, Anya, Also built a demonstrator together with CESMII for HMI this year. It was also, I believe, a battery passport, and it was a joint development project that, you know, not just CESMII and the LNI helped build, but many other consortia were involved, as far as I remember. So Dominic, you can back me up on this. So it was also a great success. Lots of people were interested in using this technology for their battery passport or digital product passport technology. So how do you put it together? Well, to describe it with my executives, I need to come up with a simplified explanation of what you really need, right? So in my world, you need 4 things to really build data interoperability. And let's take an analogy. Let's say you're an author and you want to publish a story that you just come up with, and you want to publish that story to a very wide audience because you want to sell lots of copies. So you need an interface, a data format, a data model, and some semantics to describe your story, right? So let's say you pick a book as the interface, you pick the Latin alphabet as the data format, then you pick the English language as the data model, and then finally you write your story and plot the characters of your novel, what happens when and who does what in your novel. Those are the semantics. That's the description of what really happens. So only when all 4 things are defined can you really talk about data interoperability. So then what does that look like when we put it all together for this new concept? Well, if you put it all together, you end up with something like this. So for the interface, we said, okay, we'll combine the Asset Admin Shell REST interface with the OPC UA REST interface, and then customers can decide which one they want to use. We don't really want to pick a winner here. And that's for the data plane. For the control plane in the supply chain, so basically working out a digital contract between 2 entities, but only in the supply chain, we can use one of the data space components, such as the EDC, but others can be used as well. And what you end up once this digital contract is negotiated is some sort of security token that can then be passed to the Asset Admin Shell, and that's all the EDC is used for. So for the data format, so no data flows through the EDC, the data flows through the Asset Admin Shell. That's important. So for the data format, we already mentioned it. We use the node.xml. It's a proven technology, lots of tools available for it, and it's something that, you know, we've been using with Asset Admin Shells actually for some time now. And then finally, the data model, we already mentioned it, so we're using the OPC UA information models. CESMII calls them Smart Manufacturing Profiles. The CESMII Smart Manufacturing Innovation Platform also uses them. And of course, you can use them with tools like Siemens, Sioma, and others to build your Asset Admin Shell. And then for the semantics, nothing changes. We continue to use the Asset Admin Shell meta model. We can extend that meta model with dictionary identifiers from ECLASS to give it more semantic meaning. And then finally, we can use the Asset Admin Shell submodel templates from the IDTA for the different use cases to bring it all together in a single architecture. So what does that look like when you build it? And this is a high-level architecture diagram. So this is, in fact, what the Asset Admin Shell repository contributed to the Digital Twin Consortium now looks like. So down below, you have a package service. That package service loads Asset Admin Shell packaging files, the AASX files, and it can load from different sources. And of course, the content can be the existing JSON, the existing XML that we know from the spec, but now also the OPC UA node-set files. That's the new thing. And then, of course, there's an environment service that basically has a copy of the content of the AASX file in memory. And on top of that, then, you have an OPC UA server. It's a simple, off-the-rack OPC UA server, nothing special about it, but it runs inside the Asset Admin Shell repository. And to connect it to the REST interface, we just use an OPC UA client. So the client connects to the server and dishes the data out to the REST interface of both the asset admin shell REST interface and the OPC UA REST interface. That's it. Everything else around it is just functionality for certain use cases. Of course, you can also load a nodeset file directly into the OPC UA server. So that's the top left there. So you can take a smart manufacturing profile from CESMII or any other nodeset file, including from Siemens Siome, and just load it directly into the OPC UA server. So with that, I want to show you what that actually looks like. So here is Siome. And as you can see, I've already loaded the I4 AES companion specification into Siome, so I get all the meta model defined in that companion spec to model asset admin shell. So I get something like a submodel element type or a submodel type, and I can use those to build an asset admin shell right there in the tool. When I do that, right now, I hand built this, but eventually, maybe all the submodel templates are available as companion specs, then I can just use those directly. But for now, I just model it manually. So I created two models, one called product carbon footprint, which has all the information of that roll of paper that we produced in it. And then down here, we have a nameplate, which is all the information that you would expect in a digital nameplate, again, for that roll of paper. And then I can hit this export button, and I will get a nodeset XML. And then here I have the running asset admin shell repository. You can see the roll of paper that we produced. And down here, you'll see all of the same information that you would expect from an asset admin shell with a nameplate and a product carbon footprint, but now running inside an OPC UA server, which is basically depicted here. If you know OPC UA, you have an objects folder, and then location, server, and aliases. And then down here, you have the AES root, which is basically the root of the asset admin shell that runs inside that OPC UA server. And all the information is there for the product carbon footprint. And down here, you have, here's the PCF, and here you have the nameplate. If you go to Swagger, that same location, you have the AES REST service. And now for the first time, we also have the OPC UA REST interface built into the same server. So both are available, both can be used depending on what you want to use. And that brings me to the end of my demo. So I hope you liked it. Of course, the devil's in the detail. We're looking forward to, I already have made great contacts in the last 2 days of people that want to help build this out further, which is great. It's an open source project. Anybody can contribute. Maybe I should show you this. So this is actually right here. So in the Digital Twin Consortium GitHub repository, you can see it here. It's open source, and you can contribute to it if you want to. And with that, I think I'm going to hand off to Jonathan, right?
Yeah, so listen, the question is now what we as associations, we have to say to this. So obviously IDTA welcomes this initiative. How could we not? As our own one and only mission is really to drive the adoption of the RS worldwide. So, and on top, we have here really clever standards we are bringing together, and we all know how important it is when it comes to deployment of concepts, that standards are working together and that it becomes more easy to deal with. Now, the attractiveness of the RS is really that we are able to kind of modeling assets, functionalities, systems for each step of a life cycle of assets. Consortial, open source, certified, tested, open source, as I said, under an IPR. So this is very clever. And that's why that has a big attractiveness. And I showed last week in Oak Ridge, I showed a slide from our very first presentation when we created the IDTA 4 years ago, which shows already we don't want to reinvent the wheel with the RS, but we want to take existing standards wherever it is possible, right? So if you have an extensive data description for an asset, you go with a dictionary, you take ECLASS, for instance. If you have shop floor data, which we want to pull in this case here into the DPP because we need shop floor data, energy mix, CO2, whatever, we go with OPC because it's already modeled, so we can absorb, as you see, this into. And then it was very good also in last week in the US to see that the smart manufacturing profiles, which have been done by CESMII, are there around on the market, and now we have really here a combined system which is talking to each other, and the profiles understand each other and can be used vice versa. So this is a very good thing. Erich, good job to doing this in this way. And frankly speaking, I mean, standing ovations, we are so clever and our systems are so clever as our customer will adopt it, right, and use it. So standing ovations will come for me when we see these things playing in our fields. And again, last week in Oak Ridge, we had so many end users and C-levels we talked to. This was a very nice event where those people got informed about this, saw what it does, saw what it can. This exhibition, same, right? So we have to talk about, we have to show how it plays, and then I think standing ovation will come. Thank you.
Now I have the pleasure to speak in my role as an OPC president. Obviously, we are also supporting this, and I sent Erich already my congrats. For me, it's fantastic that one key person who is able to understand language of different levels from the OT world and the IT world and business world, and bring that together. I think this is one of your key skills where maybe all or most of the other people, including me, obviously, have skills, but we should listen more to others, right? So we are obviously supporting this. It makes us proud that OPC UA is a super rich modeling language, which I believe really is not only in the context now with the asset shell and the digital product passport. I also like to bridge this a little bit what we had also today as another press release that Google Cloud joined the OPC Foundation Cloud Initiative, where you also have the who is who of cloud suppliers, Alibaba Cloud, Google Cloud, Huawei here, David is in the room, Microsoft Azure, AWS, SAP, and all of them also agreed to keep the UA context information in their cloud systems. That's a fantastic message, and so it plays perfectly here together with also the digital product passport and the asset shell. So I'm looking forward to have this cooperation. We have a joint working group between the IDTA and the OPC Foundation. All technical aspects can be handled there. We don't have to start. We are already in this partnership, and we are also cooperating with all the others here. I don't have to highlight that because you got all that information all over the years. So again, thank you, Erich. Thank you also to Thomas, and looking forward. Okay, thank you so much.
All right. Well, thank you for having me. I'm sorry that I couldn't be there in person, but I'm live at Automation Alley in Detroit, Michigan, one of the U.S.'s fine centers of manufacturing excellence. CESMII is the United States Institute for Smart Manufacturing Innovation. And we've been working For the past 5 or 6 years with our members, our membership is a consortia of manufacturers, educators, system integrators, and vendors, all focused on sort of improving the state of manufacturing here in the US. And our core thesis is that in order for manufacturers to be able to make better decisions, they have to understand their data better. So we started early on with this information modeling focus, found quickly that an OPC UA information model was the most open and compatible format that we could standardize on. And so although we are not a standards body, we work with our membership to educate on standards, to advocate for their adoption. And then me and my team participate in working groups and other standards bodies to help provide feedback from the US to those groups so that that input can be understood as part of the evolution of the standards. One of the things that we shared was a real need to harmonize the information modeling format inside the asset administration shell. We want to support both, but we don't have the same push for regulation here that has been driving innovation there in Europe. So the focus is about better decision-making for manufacturers. And having this harmonization of the information model standard inside the asset administration shell is going to grease the rails for much easier adoption. We're really excited to see that these groups came together. They had good ideas with different genesis, but the same goal to help manufacturers understand their information and be able to share that information in a structured but safe and secure way. So we're really happy to endorse this effort, to share it with our members, and to see this kind of international collaboration continue around better data, better information models for manufacturing and other industrial applications that are going to benefit from this. Thanks again from CESMII.
Thank you so much.
Okay, thank you to be here, and I would like to follow the message already mentioned here. As you maybe know, ECLASS is a semantic dictionary, offers more than 28,000 different kinds of properties to describe something, have all the ISO IC units included. But the thing is, ECLASS has one benefit, and it's the same benefit as the OPC companion specs and the AAS has. It's proven by the industry and driven by the industry. That means all the expertise is going directly to these industrial standards like ECLASS, like IDTA, like the OPC Foundation. And that's why it makes sense to get a closer look to this, because I know ECLASS perfectly fits into OPC companion specs, perfectly fits into AAS, and it's already proven that it works. And we have also built the version of the DPP, and ECLASS is also shaping on the European level at the CEN-CENELEC JTC 24, leading one of the project groups to create the standard here. And no surprise, there will be not one solution for the DPP in the future, but if you can choose, set on the solution that works, and please do not reinvent the wheel. It makes sense to look for industrial standards, and that's why I like this very, very much, what we have presented by Erich, but also presented by my former speakers. There is a running solution. It's driven by the industry, and it makes sense to set on this kind of solution. Therefore, ECLASS is contributing, of course, and I would like you to invite to shape this this year, because we are convinced of this solution here. Thank you.
Yeah, the perspective of machinery industry and mechanical engineering industry is that it is really important that technologies like OPC UA and asset administration shell are working together. The last years, we spent a lot of effort as VDMA to get in touch with both organizations, of course, but also to get these organizations together. And it is amazing that right now we have, in the example of the digital product passport, one example where exactly the technologies are working together, getting the benefits from both technologies in the best way. So basically, for our work until 2018, where we developed a bunch of OPC UA companion specifications, since then it was clear that shop floor information should be standardized. And right now, as already mentioned, it's amazing to see that these shop floor information that is relevant for some of the use cases that are relevant about the whole life cycle, where exactly AES has its major benefit, can be used as OPC UA, and the modeling is usable inside the AES. So with this, we believe that for both technologies, is really a big impact that they can be combined and that can be taken the best from both in combination for the industry. As for machinery industry, it's really important as in the shop floor and in these industries, the technologies are used together. And this means they have to be compatible and not working together. So VDMA is really heartily welcoming the initiative and the work that was done by Erich, but also for the associations that are willing to participate in this working groups and driving together for real interoperability for the whole industry. Thank you.
So, speaking for the German Electro and Digital Industry Association, I can only agree with everything we have heard before, and we also welcome this initiative to bring AES and OPC and all those closer together and show how they can work together and how to draw the big picture. Because we think that, especially regarding some topics like the digital product passport, many companies, there are big uncertainties on which methods or which systems can be used to fulfill the requirements that are coming up with the digital product passport. And from our side, we think that we need a holistic approach where all the different systems can work together in the end. For us, we are mainly working today with the asset administration shell in terms of digital product passport and DPP 4.0. Trying to bring this also in the international standardization with JTC 24. And we think the content of the digital product passport is created in the whole supply chain as well as in the manufacturing process of such products. And therefore, all data that is produced somewhere in these processes needs to be transferred, for example, via OPC UA and so on, to the asset administration shell. And from there on, we can share all the information across companies. And that is why we think that this approach is welcome, or we welcome this approach. And we hope that we can draw the whole picture. And maybe to add, digital product passport, as we talking it or discussing it today, is mainly a European topic, so European regulation. They want this digital product passport. But the idea of the digital product passport to be able to share data is not only existing in Europe, it's a global topic. And I think if we can show that we are working together here, we can show, first of all, to the European regulators, as well as to the whole world, that this system can be used to make manufacturing a better place. Thank you.